Dr. Han Soo-jin stared at her computer screen, her eyes growing wider with each passing second. The numbers didn't make sense, but they were there, clear as day. She had checked them 5 times already. This can't be right, she whispered to herself in the quiet laboratory. The clock on the wall showed 3:15 a.m., and she was the only one still working at the Korea Aerospace Research Institute. She reached for her phone and quickly dialed a familiar number. After 4 rings, a sleepy voice answered. "Taiwan, I need you to come to the lab right now." "Soo-jin, it's the middle of the night," Dr. Kim Taiwan groaned. The telescope array picked up something strange. I think we're seeing through a black hole's event horizon." There was a long pause on the other end. "I'll be there in 20 minutes. True to his word, Taiwan arrived at the lab, his hair messy and his jacket thrown on over his pajamas. He pulled up a chair next to Soo-jin and looked at her screen. "Show me," he said simply. Soo-jin pulled up the data from their deep space telescope array. "Look at these readings. We were observing the black hole in the Messier 87 galaxy, just routine observations, but these quantum signatures." She pointed to a series of numbers on the screen. "They show patterns that shouldn't exist beyond the event horizon." Taiwan leaned closer, his sleepiness forgotten. "That's impossible. Nothing can escape a black hole's gravity once it passes the event horizon, not even light." "I know the theory," Soo-jin said, pushing her glasses up her nose. "But look at these quantum entanglement readings. They're showing coherent patterns. It's like we're getting a reflection of what's inside." They spent the next 3 hours going over the data. They checked for equipment malfunctions, data corruption, and any other explanation that might make sense. They found nothing wrong. As the sun began to rise, painting the sky outside their window in shades of pink and orange, Taiwan sat back in his chair. "If this is real, Soo-jin, it changes everything we know about black holes." Soo-jin nodded, rubbing her tired eyes. "We need to verify it, run more tests, and we need help." She turned to face her colleague. "Remember Dr. Park Ji-ho, the quantum entanglement expert? From Seoul National University?" "Yes, I've read his papers." "We should call him. If anyone can help us understand what we're seeing, it's him." Taiwan checked his watch. "It's 6:30 a.m. now. Give it another hour, and we can start making calls." They spent that hour preparing their data, organizing their findings, and drinking strong coffee from the lab's old coffee maker. Both scientists could feel the excitement building. If their discovery was real, it would revolutionize our understanding of the universe. At exactly 7:30 a.m., Soo-jin picked up her phone again. As she waited for Dr. Park to answer, she looked at the numbers on her screen one more time. Those impossible, fascinating numbers that suggested humanity might finally be able to see what lay beyond one of space's greatest mysteries. The phone rang 3 times before a cheerful voice answered. Dr. Park speaking. Soo-jin took a deep breath. "Dr. Park, this is Dr. Han Soo-jin from the Korea Aerospace Research Institute. I apologize for calling so early, but we found something you need to see. It's about quantum signatures from beyond a black hole's event horizon." There was a pause on the other end. When Dr. Park spoke again, his voice was different, more focused. "Tell me everything." As Soo-jin began explaining their discovery, she knew that this ordinary morning was about to become anything but ordinary. Sometimes, the biggest changes in human history started with a simple phone call and some unexpected numbers on a computer screen. The search for answers was just beginning, and for the first time, those answers seemed within reach. Dr. Park Ji-ho arrived at the Korea Aerospace Research Institute 2 days after Soo-jin's early morning call. He walked into the conference room carrying a worn leather briefcase and a look of intense curiosity on his face. Soo-jin and Taiwan had spent those 2 days preparing their data and checking their findings over and over. They had barely slept, running on coffee and excitement. "Show me these quantum signatures," Dr. Park said after brief introductions. He pulled out his laptop and set it next to Su-jin's. Su-jin displayed the data on the large screen at the front of the room. Here are the normal readings from outside the event horizon, she explained, pointing to the first set of numbers. And here, she clicked to the next screen, are the unusual patterns we detected. Dr. Park leaned forward in his chair. He stayed quiet for a long time, studying the numbers. Finally, he turned to face them. In all my years studying quantum entanglement, I've never seen anything like this. But he paused, thinking carefully about his next words. I think I might know what's happening. He stood up and walked to the whiteboard. We know that quantum particles can be entangled, yes. When two particles are entangled, what happens to one instantly affects the other, no matter how far apart they are. Taiwan nodded. But what does this have to do with seeing inside a black hole? Dr. Park picked up a marker and began drawing. Imagine two entangled particles. One falls into the black hole, past the event horizon. The other stays outside. Traditional physics says we can't get any information from beyond the event horizon. But what if the entanglement doesn't break? Su-jin's eyes widened. The particle outside would still be connected to the one inside. Exactly, Dr. Park said, drawing more diagrams. And if we could observe many such entangled pairs in the right way, we could use them like mirrors. Taiwan finished, standing up excitedly. Quantum mirrors reflecting information from inside the black hole. Dr. Park smiled. That's my theory. Your telescope array must have accidentally aligned in just the right way to detect these quantum reflections. If we could design equipment specifically to observe these entangled particles, we could see inside a black hole, Su-jin whispered. They spent the next 6 hours developing their theory. Dr. Park's knowledge of quantum entanglement combined perfectly with Su-jin and Taiwan's expertise in observational astronomy. As evening approached, they had filled 3 whiteboards with equations and diagrams. Their theory was revolutionary, but based on solid physics principles. We need to present this to the Institute's board, Taiwan said, looking at their work, but they'll be skeptical. Everyone knows you can't see inside a black hole. Then we'll show them proof they can't ignore, Su-jin replied. She turned to Dr. Park. Will you help us design the right equipment to detect these quantum reflections properly? Dr. Park looked at the whiteboards, then at the data still displayed on the screen. This could be the biggest discovery in the history of physics. Of course I'll help. They began drafting their presentation that same night. They knew many scientists would reject their theory at first. That's how science usually worked. New ideas often faced strong opposition before being accepted. But they also knew their data was real. The math worked. The physics made sense. They just had to prove it to everyone else. As they worked late into the night, none of them realized they were about to start a project that would change humanity's understanding of the universe forever. Sometimes the biggest scientific breakthroughs came from asking simple questions about impossible things. And the question they were asking was simple indeed. What if we could see a black hole? The presentation room at the Korea Aerospace Research Institute was completely full. Scientists from different countries sat shoulder to shoulder, their eyes fixed on the screen at the front of the room. Su-jin stood before them, her heart beating fast, but her voice steady. And that's why we believe we can observe beyond the event horizon. She finished, looking at the crowd of serious faces. The room stayed quiet for a long moment. Then, from the back of the room, someone stood up. It was Dr. Yoon Mi-rae, one of the world's leading experts on black holes. She had flown in from America just for this presentation. Dr. Han, Mi-rae said, her voice clear and strong. What you're suggesting goes against everything we know about black holes. But, she paused, looking at the data displayed on the screen. Your evidence is very convincing. I would like to join your team. The room burst into excited discussion. More scientists began raising their hands, asking questions, offering support. In the front row, Lee Do-hyun, the Institute's mission director, was already making notes on his tablet. After the presentation, Do-hyun called the team to his office. The government has agreed to fund the project, he said, showing them the approval document. We're calling it Project Horizon. Dr. Yoon will join as our senior astrophysicist and will have support from space agencies around the world. Soo-jin looked at Ta-won and Dr. Park, seeing her own excitement reflected in their faces. When do we start? She asked. Right now, Do-hyun replied. He pressed a button on his desk phone. Send in Mr. Choi, please. A few minutes later, Choi Sun-woo walked in. He was the Institute's best technical director, known for solving impossible engineering problems. We need to build a special satellite, Do-hyun explained to Sun-woo. One that can detect quantum-entangled particles around black holes. Can you do it? Sun-woo studied the designs that Soo-jin and her team had prepared. It won't be easy, he said finally. We'll need new types of sensors, special shielding. But yes, we can build it. The next few months passed in a blur of activity. The project team grew as more experts joined from different countries. They converted a whole floor of the Institute into their workspace, filling it with computers and equipment. Mi-rae worked closely with Soo-jin and Ta-won, helping them refine their theories. Her experience with black holes proved invaluable as they designed the satellite's observation systems. The hard part, Mi-rae explained one day while they were reviewing the plans, will be filtering out all the noise. Space is messy. We need to be sure we're only seeing the quantum reflections. Sun-woo and his engineering team worked long hours in the laboratory, building and testing the special sensors. They failed many times, but each failure taught them something new. One evening, as Soo-jin was leaving the institute, she saw lights still on in the engineering lab. Inside, Sun-woo was working on a new sensor design. You should get some rest, she told him. He looked up from his work. Soon, he said with a tired smile. We're close to getting it right. I can feel it. She understood how he felt. They were all pushing themselves, working harder than ever before. But this wasn't just another science project. They were building something that could change our understanding of the universe forever. As she walked to her car that night, Soo-jin looked up at the stars. Somewhere out there, a black hole was waiting to share its secrets, and soon they would be ready to listen. The morning of the launch was clear and cool at the Neuro Space Center. Soo-jin stood with her team, watching as technicians made final checks on their satellite, Hongik 1. The name meant widely benefiting mankind, and they all hoped it would live up to that promise. Sun-woo walked around the satellite one last time, his tablet showing a long checklist. He had barely slept in the past week, personally supervising every detail of the final preparations. The quantum sensors they had developed were extremely sensitive. Everything had to be perfect. All systems are green, he reported to Mission Director Do-hyun. We're ready for loading. Do-hyun nodded and spoke into his headset. Begin transfer to the launch vehicle. The team watched as their satellite, the result of 18 months of intense work, was carefully moved to the rocket. Soo-jin felt Ta-won's hand on her shoulder. Remember when this was just some strange numbers on your computer screen? He asked quietly. Soo-jin smiled. Sometimes I still can't believe we made it this far. Dr. Park and Mi-rae joined them, both wearing the project's blue uniforms. They had all grown close over the months of working together, united by their shared goal of seeing the impossible. The quantum sensors are our eyes, Dr. Park said, watching the loading procedure. But Mi-rae's calibration system, that's the real breakthrough. Without it, we'd never be able to filter the data properly. Mi-rae shook her head modestly. The breakthrough was Soo-jin's original discovery. We just helped build the tools to prove it. 3 hours later, they gathered in the control room. The rocket stood ready on the launch pad, carrying their hopes and dreams into space. Screens around the room showed different aspects of the mission: weather data, rocket systems, launch trajectory. T-10 minutes, the launch controller announced. Do-hyun turned to address the team. Whatever happens today, you've already made history. This is the most advanced quantum observatory ever built. Be proud. The final minutes ticked by slowly. Su-Jin found herself holding her breath as the countdown reached its final stages. T-minus 10 seconds. 9. 8. The rocket's engines ignited, sending a bright flame across the launch pad. 3, 2, 1. Liftoff. The rocket rose slowly at first, then faster and faster, pushing against Earth's gravity. Everyone in the control room watched the telemetry data, checking for any signs of problems. First stage performing normally. Sun-Woo reported, his eyes fixed on his screen. Trajectory is nominal, another controller added. Minutes passed as the rocket climbed higher. They watched as it passed each milestone. First stage separation, second stage ignition, payload fairing separation. Each successful step brought sighs of relief. Finally, after what seemed like hours but was really just 45 minutes, they received the signal they had been waiting for. Satellite deployment confirmed. Sun-Woo announced, Hongik-1 is in orbit. The control room erupted in cheers and applause. Su-Jin hugged Tae-won, then Dr. Park, then everyone else within reach. They had done it. Their observatory was in space, but the hardest part was still to come. Now they had to prove that their theory was right, that they really could see beyond a black hole's event horizon. As the celebration continued around her, Su-Jin looked at the main screen showing their satellite's orbit. Somewhere up there, Hongik-1 was beginning its mission, carrying humanity's hopes of understanding one of the universe's greatest mysteries. The real work was about to begin. 2 weeks after the launch, the control room at the Korea Aerospace Research Institute was quiet. The excitement of the launch had given way to the patient work of calibrating Hongik-1's sensitive instruments. Su-Jin sat at her workstation, carefully reviewing the incoming data. The quantum sensors were working perfectly, but they hadn't detected anything unusual yet. Next to her, Mireille adjusted the filtering algorithms, trying to remove the background noise of space. The calibration sequence is complete, Sun-Woo announced from his station. All systems are operating at full capacity. Tae-won walked in carrying fresh coffee for everyone. He had just finished a video call with Dr. Park, who was monitoring the data from his laboratory. Dr. Park says the quantum entanglement readings are stable. We can begin our first official observation of the target black hole. Su-Jin took a deep breath and nodded. Start the sequence. The room grew even quieter as the satellite turned toward their target, the supermassive black hole at the center of the Messier 87 galaxy. This was the same black hole where Su-Jin had first detected the strange quantum signatures. Approaching optimal alignment, Mireille reported, her eyes fixed on her screen. Quantum sensors are active. The first data began appearing on their screens. At first, it looked normal, exactly what they would expect to see around a black hole. But then something changed. Wait, Su-Jin said, leaning closer to her monitor. There's something different in the quantum signature pattern. Tae-won rushed to look at her screen. It's similar to what you found before, but much clearer. Mireille quickly adjusted her filtering algorithms. The pattern is getting stronger. Whatever we're seeing, it's definitely coming from beyond the event horizon. Su-Jin felt her heart racing as she watched the data flow in. The numbers were forming clear patterns now, too organized to be random space noise. They were seeing something that had never been seen before, information from inside a black hole. Look at this structure, Tae-won said, pointing to a repeating sequence in the data. It's almost like it's organized. Su-Jin finished his thought, like something or someone arranged it this way. The team worked through the night, analyzing the patterns. They checked and double-checked their instruments, ran multiple confirmations, and verified every piece of data. There was no doubt. They were receiving coherent information from inside the black hole. At dawn, Mission Director Do-hyun called an emergency meeting. The team presented their findings, showing how the patterns suggested an organized structure within the chaos of the black hole. Are you saying this might be artificial? Do-hyun asked, his voice serious. We don't know yet, Su Jin answered honestly. But these patterns, they don't look natural. We need more time to study them. Whatever it is, Myray added, it's the first time anyone has received clear information from inside a black hole. That alone is a revolutionary discovery. As the meeting ended, Su Jin stayed behind in the control room, staring at the flowing data on her screen. She thought about all the scientists throughout history who had studied black holes, always seeing them as endpoints, places where information disappeared forever. But now they knew different. Black holes weren't just cosmic dead ends. They were holding something, patterns, information, maybe even messages. And for the first time in human history, someone was listening. 1 month after their initial discovery, the control room had transformed. The walls were now covered with printouts showing different versions of the pattern they had detected. Myray had created large charts tracking how the pattern changed over time. The sequence repeats every 6 hours, she explained to the team during their morning meeting. But it's not exactly the same each time. There are small changes, like variations in a message. Su Jin nodded, pointing to one of the charts. We've confirmed it's not natural. These patterns show signs of mathematical precision that doesn't exist in nature. The team had grown. Scientists from around the world had joined their project, all working to understand what they were seeing. But today, they had an important visitor. Kang Min-ho walked into the control room, carrying a small laptop. He was one of the world's best quantum computing experts, and Do-hyun had invited him to help analyze the patterns. Dr. Kang, Do-hyun said, greeting him. Thank you for coming. We need your expertise. Min-ho looked at the charts on the walls with great interest. I've reviewed the data you sent. These patterns, they remind me of quantum computing code. The room grew quiet. Su Jin and Taiwan exchanged looks. They had suspected something similar but needed confirmation from an expert. Show me your latest readings, Min-ho requested. Myray pulled up the most recent data on the main screen. The pattern flowed across it like a digital river, full of complex mathematical relationships. Min-ho studied it carefully. After several minutes, he spoke. This is definitely a form of communication. The mathematical structure is too perfect to be anything else, but it's using principles of quantum computing that are far beyond our current technology. Are you saying, Taiwan paused, choosing his words carefully, that someone left a message inside the black hole? Not just a message, Min-ho replied. Based on what I'm seeing, this might be an entire library of information, stored in quantum states. Whoever created this understood things about quantum mechanics that we're only beginning to discover. Su Jin felt a shiver run down her spine. Their project had started as an attempt to see inside a black hole. Now they were finding evidence of an advanced civilization that had used black holes to store information. How do we decode it? She asked. Min-ho opened his laptop. The principles are similar to our quantum computing, just much more advanced. With your permission, I'd like to join the team. I think I can help build a system to translate this data. Do-hyun didn't hesitate. Welcome to Project Horizon, Dr. Kang. They worked late into the night, combining Min-ho's quantum computing knowledge with their existing research. The patterns began to make more sense as they viewed them through this new lens. Look at this section, Myray said excitedly, pointing to a recurring sequence. It's like a key, showing us how to read the rest of the data. Su Jin watched the team work, feeling a mix of excitement and wonder. They had hoped to learn about black holes, but they were discovering so much more. Someone, somewhere in the universe, had found a way to use these cosmic giants as storage devices for their knowledge. As she looked at the flowing patterns on the screen, Su Jin wondered what secrets they might contain and what they would learn when they finally decoded them. 2 days after Min-ho joined the team, the control room buzzed with new energy. He had set up a special quantum computer system that could help decode the patterns they were receiving from the black hole. The key is to think of it like layers, Min-ho explained as he typed on his keyboard. Each quantum state holds multiple levels of information. It's like reading a book where every page has many more pages hidden inside it. Sujin and Myray worked with him, feeding the satellite data directly into his system. Taiwan and Dr. Park watched the main screen, where the decoded information would appear. Starting decode sequence, Minho announced. The room grew quiet except for the soft hum of computers. At first, nothing happened. Then, slowly, numbers began appearing on the screen. But these weren't random numbers. They formed a clear mathematical sequence. "It's prime numbers," Taiwan said, his voice filled with wonder. The first 1,000 prime numbers, arranged in a perfect spiral pattern. A test message, Myray realized. Something any advanced civilization would recognize as artificial. Minho nodded, his fingers flying over the keyboard. And there's more. This is just the first layer. The pattern goes deeper. The team worked through the night, carefully decoding layer after layer of information. Each new level revealed more complex mathematical concepts. Some were familiar, others completely new to human mathematics. Around midnight, Sujin noticed something different in the data. "Look at this sequence," she said, pointing to her screen. "It's not just math anymore. These patterns, they're forming images." Minho quickly adjusted his program. The main screen flickered, and then a series of diagrams appeared. They showed strange but beautiful geometric shapes that seemed to move and change as they watched. "These are quantum equations," Dr. Park said, studying the diagrams. "But they're far more advanced than anything we've developed. They show how to manipulate quantum states in ways we never thought possible." As they continued decoding, more information emerged. The message contained detailed scientific knowledge about quantum mechanics, space-time, and the nature of black holes themselves. It was like finding a textbook written by teachers from an impossibly advanced civilization. "Whoever left this message," Myray said softly, "they wanted it to be found. They wanted to share their knowledge." Around dawn, they made another breakthrough. Minho's system decoded a new layer that was different from the others. Instead of equations or diagrams, it contained what looked like a star map. "These aren't just random stars," Sujin said, studying the map. "This is a record of their civilization, where they came from, where they went. They left us their whole story." The team gathered around the main screen, watching as more of the star map appeared. Each point of light represented a place where this ancient civilization had lived, explored, or built something. The map spanned thousands of light years and showed millions of years of history. As the sun rose outside, painting the sky in shades of pink and gold, the team realized they were reading the greatest library ever created. Someone had turned a black hole into a message bottle, floating in space until another civilization was ready to find it and learn from it. The real question now was, were they ready for what they would learn next? 1 week after discovering the star map, the Korea Aerospace Research Institute held a special meeting. Scientists from around the world gathered in the large conference room. The team had made an important decision. It was time to share their full findings with the world. Sujin stood at the podium, facing the crowd of eager faces. Behind her, the main screen showed the decoded messages they had found. Minho sat nearby with his quantum computer, ready to demonstrate their discoveries. "What we found in the black hole changes everything we thought we knew," Sujin began. "Black holes are not destroyers of information. They are the universe's perfect storage devices." She gestured to the screen, where the star map appeared. The civilization that left these messages discovered this truth long ago. They learned that a black hole's perfect gravity makes it ideal for storing quantum information. They turned black holes into libraries. Myray stepped forward to explain the next part. These libraries contain the collected knowledge of their civilization, but they didn't just store their own information. They found other libraries in other black holes, left by even older civilizations. Each one added their own knowledge before passing it on. "It's like a cosmic chain letter," Taiwan added, passed down through millions of years. Each civilization learns from those who came before, then adds their own discoveries. Minho demonstrated how the quantum storage worked, showing how one simple pattern could contain layers upon layers of information. Dr. Park explained how this discovery would change physics forever. Then Sujin revealed their biggest finding. "The messages tell us something amazing," she said. "Our universe is not the first. There were others before it, and there will be others after. Black holes are the only things that survived from one universe to the next. That's why these civilizations used them for storage. They knew their knowledge would survive even if their universe ended." The room was completely silent as everyone absorbed this incredible news. But the most important message, Sujin continued, was meant specifically for civilizations like ours, those just beginning to understand black holes. It's an invitation. She showed the final decoded message on the screen. It was simple but powerful. "Add your story to ours." They want us to learn from their knowledge, she explained, and then add our own discoveries to the library. We're being invited to join a chain of civilization that stretches across universes and time itself. As the presentation ended, the room erupted in excited discussion. Scientists began planning new research projects, thinking about what humanity could contribute to this cosmic library. Later that evening, the original team gathered in their control room. They looked at the flowing data on their screens, the message from across time and space that they had learned to read. "So what do we do now?" Ta-1 asked. Sujin smiled. "Now we learn everything they can teach us, and then we add our own chapter to the story." She looked out the window at the night sky. Somewhere up there, Hongik 1 was still circling Earth, its quantum sensors reading the ancient messages stored in a black hole's perfect gravity. Their discovery had changed humanity's place in the universe. They were no longer alone in the cosmic story. They were part of something much bigger, a great chain of civilizations, each learning from the past and preserving knowledge for the future. And it had all started with a simple question. What if we could see a black hole?